Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers and viewers. Here is another video in Engineers in Progress about mixture problems. I hope that this video can help you improve your thinking skills, analytical skills, so that you will quickly formulate equations, especially when confronted with translation, English translation, and you have to comprehend the statement and transform it into or translate those statements into algebra. So the principle behind these mixture problems is in the preceding video. So just go over with that. Then if you want to anticipate the solutions to these problems in this video here, you can by pausing the video. And that's part of your training also. So the first problem, British sterling is 7.5% copper by weight. How many grams of silver must be mixed with 150 grams of an alloy that is 10% copper in order to make sterling? So take note that we are talking here of British sterling, and for it to be British sterling, then it should be 7.5% copper by weight. Then if the question is how many grams of silver must be mixed with 150 grams of an alloy that is 10% copper in order to make sterling, silver is 0% copper. Take note of that. So let's call X as the amount in grams of silver that must be mixed with 150 grams of an alloy that is 10% copper. So 0 times X plus 10% times 150, then equals 7.5 times quantity, the total amount to be x plus 150. So equals 7.5 times quantity x plus 150. So 10 times 150 minus 7.5 times 150 equals 7.5x, or 1,500 minus 7.5 times 150, because this is 1,500. Then transpose 7.5 times 150 to the left, so minus 7.5 times 150 equals 7.5x. Using your calculator, x is 50 grams of silver must be used in order to produce British sterling. Problem 12. The minimum standard for a shipment of gravel is that 85% of the gravel should drop through a screen of a certain size. One load of 6 cubic yards tested at only 65%. So how much gravel testing at 90% must be added to the 65% load to make it acceptable? So for the solution, 90% of x, so let us denote the number of square yards of gravel testing 90% as x, so 90 times x, then plus 65% times 6 yards, then it is equal to 85% to make it acceptable. 85 times quantity x plus 6. So 90x minus 85x is 5x in the left side, and in the right side, 85 times 6 minus 65 times 6, or 20 times 6. 5x equals 20 times 6, or 120. So x is 120 over 5, and that is equal to 24 cubic yards. So that's the amount of gravel testing 90% that should be used for it to be acceptable. Problem 13, how much 20% hydrochloric acid must be mixed with 40 milliliters of 8% acid to form 12% acid that is needed in an experiment? So let's call it X at 20% hydrochloric acid. So X, 20 times X, then plus 8 times 40, then equals 12 times quantity x plus 40. So 20 times x plus 8 times 40 ml equals 12% quantity times x plus 40. So 20x minus 12x is 8x in the left side, and in the right side 12 times 40 minus 8 times 40, and that is 4 times 40 or 160. So 8x equals 12 times 40 minus 8 times 40, that's 160. So x is 160 over 8, and that is 20 ml. So that's it for that problem. Problem 14, only 5% of the area of a city could be developed into parks, whereas in the unincorporated area outside the city limits, 25% of the area could be developed into parks. If the city covered 300 square miles, how many square miles of suburbs had to be annexed so that the city could develop 15% of its total area as parks? So the question, how many square miles of suburbs had to be annexed so the city could develop 15% of its total area? So it is 25 times x. So for the city, 5% times the area, which is 300, then plus 25 times x, then it is equated to 15% of quantity 300 plus x. So simplifying, 25x minus 15x is 10x in the left side. In the right side, 15 times 300 minus 5 times 300, so that is 10 times 300. So 10x equals 10 times 300. So cancel out 10. X therefore is 300 square miles also of suburbs area. Problem 15, Lynn, a chemist mix 40 milliliters of 8% hydrochloric acid with 60 ml of 12% hydrochloric acid solution. She used a portion of this solution and replaced it with distilled water. If the new solution tested 5.2% hydrochloric acid, how much of the original mixture did she use? So first, we do not know the resulting concentration of hydrochloric acid in the mixture. So we'll first solve it, and we will call X as the amount portion of that resulting solution, and to be replaced with distilled water. And take note, distilled water is 0% hydrochloric acid. And the total amount is still 100 ml. So 48 times 40 plus 12 times 60 equals the resulting concentration times 100 ml, because 40 times 60 is 100 ml. 100 ml. So the resulting concentration is 10.4% hydrochloric acid. Then we replace a portion of this x by distilled water. So 0 times x, because distilled water is 0% hydrochloric acid, 0 times x, then plus the original concentration 10.4 times quantity 100 minus x, then we equate it to 5.2. The resulting mixture is now 5.2 of quantity 100, because the amount is still 100. X plus 100 minus x is still 100 ml. So 10.4 negative 10.4x to the right, so it is 10.4x. Then 10.4 times 100 minus 5.2 times 100, that would be 5.2 times 100 in the left side. So 5.2 times 100 equals 10.4x in the right side of the equation. Since 5.2 divided by 10.4 is 1 half, so 1 half of 100x therefore is 50 ml of distilled water is also the amount that is replaced with distilled water. So the original mixture, the resulting mixture, the amount that is used is 50 ml and replaced with 50 ml of distilled water. So that's the answer. Then problem 16. One alloy contains 50% gold by weight and another alloy contains 5, 55% gold, how many grams of each alloy should be combined to make 40 grams of an alloy that contains 70% gold? So we'll call it for the 80% for the alloy that contains 80% gold, that's called the amount to be used as X, so 80X. Then plus 55 times 40 minus X, the total mass is 40. So plus 55% times quantity 40 minus X, then equals 70% times 40, 40 grams. So that's the still the amount. 80x minus 55x is 25x in the left side, and in the right side is 70 times 40 minus 55 times 40. That would be 15 times 40. X therefore is 15 times 40 over 25, so X is 24 grams of 80% gold, and the other one is 40 minus X, 40 minus 24, so 16 grams of 55% gold alloy. So problem 17, how many pounds of a 35% salt solution and how many pounds of a 40% salt solution should be combined so that 50 pounds of a 20% salt solution are obtained? So we will call the amount of salt, 35% salt solution, as X, and to be combined with 14% salt solution, we will call that 50 minus X, because the total amount after we combine these two solutions is 50 pounds of 20% salt solution. So 35 times X plus 14 times quantity 50 minus X equals 20% times 50. 35x minus 14x is 21x. And in the right side is 20 times 50 minus 14 times 50. 20 minus 14 is 6, so 6 times 50. Solving for x, 6 times 50 over 21, so that is 14 and 2 over 7 pounds of 35% salt solution. And the other one is 50 minus x, and that is 35 and 5 over 7 pounds of 14% salt solution. Problem 18, tea worth $4.10 per pound is to be mixed with tea worth $4.9 per pound. How many pounds of the more expensive tea should be used to obtain 25 pounds of a blend worth $4.4 per pound? So 4.9 times X, because this is the more expensive tea. Then plus 4.1 times quantity 25 minus X. That should be the amount in pounds for the cheaper tea. Then equated to 4.4, because this is the resulting blend, 4.4 price, 4.4 times 25 pounds. So 4.9 minus 4.1 of X is 0.8X in the left side, and in the right side 4.4 times 25 minus 4.1 times 25, 4.4 minus 4.1 is 0.3 of 25 pounds. Solving for X, 0.3 times 25 over 0.8, X is 9.375 pounds of tea worth $4.9 per pound, the more expensive tea. Problem 19, perfume to sell $80 an ounce is to be a blend of perfume selling for $104 an ounce and perfume selling for $50 an ounce. If 270 ounces of the blend are desired, how much of each kind of perfume should be used? By the way, for my viewers and subscribers, students, the problems here are taken from books by William Hart, College Algebra by William Hart, uh, College Algebra by Sparks and Rees, those are the authors, and by Lighthold. I do not remember the edition, but those authors popular authors in algebra. So for our solution, we have 104 times x. Let's call x as the number of ounces used to be blended with the perfume worth $50 an ounce. So 104 times x, then plus 50 times quantity 270 minus x. The total volume is 270 ounces, or total weight in ounces. Then it is equated to $80 times 270. So 104x minus 50x is 54x. And in the right side, it is 80 minus 50 is 30 of 270. 80 times 270 minus 50 times 270, it's like 30 times 270. 80 minus 50 times 270, so 30 times 270. Solving for x, 30 times 270 over 54, so x is 150 ounces of perfume selling $104, and 270 minus x is equal to 120 ounces of perfume selling $50 an ounce. Problem 20. A radiator contains 25 quarts of water and antifreeze solution, of which 60% by volume is antifreeze. How much of this solution should be drained and replaced with water for the new solution to be 40% antifreeze? So the question is, how much of the solution should be drained and replaced with water so the new solution to be 40% antifreeze? So we will call the amount as x, and take note it should be drained and replaced with water. So water is 0% antifreeze, so 0 times x, then plus 60% quantity 25 minus x, then the result is 40% of antifreeze solution. So the amount is still 25 quarts because we drained it, then replace it with x distilled water or water. So the resulting volume is still 25 quarts. So 40% times 25. So we have 60 times 25 minus 40 times 25. That would be 20 times 25 in the left side, and negative 60x to the right, so equals 60x. So 20 times 25 equals 60x. So x therefore is 20 over 60. That's 1/3 of 25. Therefore x is 8 and 1/3 quarts. So that's it for that problem. Then lastly, problem 21. A chemist mixed 60 milliliters of a 20% sulfuric acid solution to 40 milliliters of a 10% sulfuric acid solution. Why is there no solution to this problem if the resulting mixture is 8% sulfuric acid? So remember that in mixture problems, if you combine two mixtures, one is 20% sulfuric acid and the other 10% sulfuric acid, the resulting mixture should be within this range, 10% and 20%. So it should be between 10 and 20. For example, 10 point something, 11, 12, 13, up to 20. But since the resulting mixture is 8%, which is outside that range, so if you solve this problem, there will be no solution, or the resulting value would be negative, or there's no solution really to this problem. So that, remember the principle. The resulting concentration should be between the two concentrations that are to be mixed together. So since 8% falls outside 10 to 20%, so that's why there's no solution to this problem. So that's it, and I hope that you gain another important technique. You enhance your skills in answering problems in mixture problems, because this, though the analysis is light, this can help you improve your thinking skills in preparation to engineering life.